Hello and welcome to EE233. I'm your instructor, Gregory Myers. In this video, we're going to take another look at for loops. This video is part of a larger series of videos under your fundamentals demo. And this video also assumes that you've watched the introduction to for loops video, or also known as for loops _01. So in this video, I want you to go ahead and make a new function called for loops _02. You can grab a copy of this snip or simply take a screen capture and go ahead and write the code. In this case, we're going to bring over our prototypes as well as the function implementation, and we just simply included them at the bottom. Much like the earlier example, this also has sort of a little template in here, if you would, for our table. Now, the whole purpose with this particular example is that we are going to demonstrate nested for loops. So sometimes what you have is you have an operation that might be reliant on two conditions. And so in this particular case, what we're going to do is we're going to look at a couple of examples, one using integers and one using doubles. And specifically what we're going to do is we're going to show you then how two for loops, one inside of another, behaves. So to begin with, what I want you to do is I simply want you to make a copy of your table here, this table template, because we're going to be using it a couple of times here. And so to begin with, what we're going to do is we're going to start off with integers, and integers rather as the iterator variables. And the best example that I always like to use here is how would you use a programming language to create a multiplication table? And so the idea here is, if you recall back to when you were first learning the multiplication table, is essentially you would pick a row or a column on the table and you would simply work either across or down. And essentially what you would do is you would multiply two values together, and you would hold one of those values constant, and you would essentially loop through or increment the second value. So if you were to look at it going across on the first row, so in other words, you were multiplying 1 times 1, 1 times 2, 1 times 3, and so on, all the way through to, let's say, 1 times 12. And once you got done with that 12th value, then what you would do is you would go down and you would go to the next row, or for that first value would then become 2, and then you would start back over with the second value of 1, and then 2 times 1, 2 times 2, 2 times 3, and so on. So the idea here in this example is that we're essentially going to demonstrate how you're going to do that in the C programming language. So to begin with, you'll notice that we have two temporary variables, our index outer and our index inner. And those are probably rather long, but they're intended for this example to sort of demonstrate then the behavior of the two loops. But you clearly would want to use more appropriate variable names when you're specific to an application, although you do want to try to avoid things like simply I and J unless you're dealing perhaps with the complex numbers. So to begin with, let's start with our outer for loop. So we simply have for index outer. And much like in the earlier example, we want to initialize it to a value. Earlier, we initialized it to 0. In this case, I'm also going to initialize it to 0, but I also want to leverage then a relationship between what you'll see as an index and an array later and this value. But we'll do that in just a second. Instead, what I want to do is I want to initialize this one to 1. And I want to continue this loop while our index outer is less than or equal to 12. And then I simply want to increment the index outer. And as we said in the earlier video, we can use the longhand notation here of index outer equal to index outer plus 1. At some point, we will probably abandon this and use the shorthand notation. But to begin with, I really want you to appreciate how this loop works. Now, For the inner for loop, we want to do the same thing. So we'll start off with another for statement, a for keyword, and then for index inner. And likewise, what I'm going to do is I'm going to initialize it at 1. And I want to build this multiplication table out to 12 times 10. And the reason I want to do 12 times 10 is because I want us to have sort of an asymmetric table. Once again, this will make sense in a later example why we want to go about doing this. But I want to emphasize the asymmetry here. So in this case, my index inner is going to be less than or equal to 10, or continue until while index inner is less than or equal to 10. And then index inner equal to index inner plus 1. Now, inside of this nested for loop, we will essentially do a multiplication between the two indices here. So we're going to use the two indices to fill out our multiplication table. And the important thing to note here is that this section of code right here will run once, not only for every iteration of the inner for loop, but will also run for every iteration of the outer for loop. So in other words, the way you know how many times this code will run is you multiply the index inner times the index outer will tell you the total number of times this code will run. Now, we looked at earlier examples where our for loop may increment or decrement or potentially run 0 times. All of that still hinges on how many times either of these loops run. So what you do is you take a look at the loops individually. In this particular case, you look at how many times this loop will run, and then you multiply it by how many times the outer loop will run. And so our goal here with this example is now to print out a table that will hopefully help you understand how nested loops run. And so to begin with, what I want to do is I want to use a printf, and I'm going to simply have two placeholders separated by a comma. So a %d, comma, %d. Those are going to be my two indices. And then, as I mentioned earlier, I'm just going to simply multiply the two values together in hopes of getting another %d. So the first %d is going to be filled up with my index outer. The second placeholder, the second %d, is going to be filled up with my index inner. And then the third placeholder is just simply going to multiply the two. So in this case, index outer times my index inner. And once again, you want to leverage NetBeans in matching your parentheses. Here you can see that we've matched now the outer parentheses for the printf. And then, of course, make sure that you have your new line in there. At this point, we're ready to see how this works. So I'm going to go ahead and build it. So far, so good. We want to add this now to our list of functions that can be handled through our if, else, utilizing our command line switches. In this case, we can actually just borrow from the earlier example of our for loops _01 and simply change then the value of the switch and also the value of the function that's being called. And lastly, probably not a bad idea to simply update our help to reflect the additional switch. All right, once again, we'll build it and then we'll jump out to the command line and we'll see how our new function works. All right, so I'm going to go ahead and clear my screen. I'm going to run my fundamentals demo now with my new switch option, for loops underscore 02. And you'll see actually a lot of values. We could have probably shortened this one up for the first one. But you'll notice here, if you scroll up, you'll see that it starts with 1, 1. In other words, the outer loop runs for the first time. The inner loop runs for the first time. So index for the outer loop is 1. Index for the inner loop is 1. 1 times 1 is 1. Not a big surprise there. Now what happens is the outer loop runs still in the first iteration, but the inner loop has now incremented to 2. 1 times 2 is 2. 1 times 3 is 3, and so on. So let's take a look at the code, see if that makes sense. So if you come back down here to our example, we're going to try to split the screen here. And essentially what we're doing here is we are playing computer. In other words, what we're doing is manually stepping through the code or bench testing our code to make sure that we actually understand what it's doing with respect to our output here. All right, so if you take a look now, the outer index starts at 1, or index outer starts at 1. The index inner starts at 1. 1 times 1 is 1. So far, so good. Tell you what, let me go ahead and move this over ever so slightly so we can get both of them in there. All right, good. Now, we're still inside of our inner for loop here. In other words, when we come back around to this inner for loop, we've now incremented our inner index inner rather, to 2. 2 is still less than or equal to 10. So we're going to run this inner for loop once more to get us 1, 2 is equal to 2, or 1, 2, and then 1 times 2 is 2. We increment the index inner one more time. That value then becomes 3. 3 is still less than 10, and so on. And we keep on going until the index inner is equal to 10. So 10 is still less than or equal to 10. So then we run it we're now on this example right here, 1, 10. And of course, 1 times 10 is 10. And so now when we come back around, we have incremented our index inner to 11. 11 is no longer less than or equal to 10, which kicks us out of our inner for loop. That bumps us now to the outer for loop. We have incremented our index outer to 2, and we start over the process now with the inner for loop. So in this particular case, then we're now here on this line, 2, 1, and 2 times 1 is 2. And then we simply repeat the process with the inner for loop another 9 times until we're at 2, 10. 2 times 10, of course, is 20. And then once we get to 11 on the inner for loop, we simply are bumped out of this inner for loop again because we no longer, this condition right here is no longer valid. We jump out to the outer for loop. The value is now 3 for the index outer, and we reset the index inner equal to 1. So basically now we're at 3, 1. And we simply repeat this all the way through until we have essentially our multiplication table handled for up to 12 times 10. Now I realize that this doesn't look like much of a table. We'll come back to that in just a second. I'll show you how to turn it into a more sophisticated looking table. We can, of course, do the same thing now with the inner and outer loops being driven by a double and or an integer. So in this particular case, what we want to do is we'll make one more copy of our little table, or actually a table. We'll do the table a little differently when we actually demonstrate how this is done, make it look a little more like a multiplication table. So in this case, we'll just simply uncomment this. I want to just do another example here. Very similar to this one, but in this case, what I want to do is I want to use a double. And in this case, what I want to do is I want to start my double for my outer from 0, or actually from 1 rather. So in this case, it's going to be for current outer equal to 0.0, current outer less than. In this case, what we're going to do is we're going to stop it while, or continue it while it's less than 10. So my goal here is I'm going to go from 0 up to 9. And I want to increment it here. So current outer, we'll come back to our command window in just a second, is equal to current outer plus, in this case, I'm just going to add 1 to it. And then for the inner one, we're going to do something a little bit different. We're actually going to use values of pi. And so in this particular case, what I'm going to do is I'm going to go from 0 to 2 pi, utilizing increments of pi over 4. And so basically my goal here is I want to build a little table, if you would, of the multiples of pi. So in this case, we're going to start off with the current inner equal to 0. For our current inner, we want to continue it while it is less than 2 times m underscore pi. And just for a refresher on that, you can always just simply highlight and then right-click, navigate, go to declaration. You'll see that it's part of our math.h. There's your approximation for pi. And we said we want to now increment it in values of pi over 4. So in this case, this is where we want to leverage now a value other than just simply a 1.0 or 1. So in this case, what we'll say is current inner equal to current inner, and we'll actually throw a little calculation in here, plus our m pi divided by 4. And go ahead and put a space in here just to be consistent. So it looks nice. Remember that the spaces are not required here. And now what I want to do is I simply want to print these values to the table. I do, however, want to change this from index to simply read current. And all I'm going to do now is I'm going to multiply my current outer times my current inner. So nothing too terribly different than what we did before. The big difference, of course, is that we're not dealing with integers, so it's not going to be %d. Let's go ahead and up our number of decimal places to %.4f, at least for the second value. So we'll do %.2f and %.4f, and then tab over, and then for the two values multiplied together, we will go ahead and keep it to %.4f followed by a new line. We'll see if we need to tweak those a little bit. We're not worried if the table looks perfect here. The goal is just to see the behavior. So in this case, it's going to be the current outer for the first placeholder, the current inner for the second one, and then for the third placeholder, I'm simply going to multiply my current outer times the current inner. All right, so let's go ahead and save it. And I'll tell you what we're going to do is just to minimize the amount of noise that we saw. It's up to you if you want to do this, but I'm going to go ahead and comment this out. Go ahead and build it. I'm only doing this so that we have less on the screen. Now, if I run this, you'll see that in this case, it's not a big surprise. 0 times any value for pi is just simply going to be 0. 1 times any value of pi, or any increment of pi, is just going to be that value. So that doesn't seem that surprising. All the way down to, in this case, 9 times the value here. So once again, notice where we're stopping. I'm actually intentionally stopping less than 2 times pi. And I'm also stopping less than 10. The earlier video, we saw that you can't use the less than or equal to with doubles like you used with the integers. All right. This brings us now to our third example, in which case I want to clean up our multiplication table a little bit. And I'd also like to go ahead and introduce the idea of a relationship now between the index and the value, or rather separate out the distinction a little bit further using a relationship between the index and the value that we're ultimately calculating. So we'll benefit from this later on. Might seem a little strange to do this now, but in the third example, what we're going to do is we're going to go back to this index outer and the index inner, and we're going to redo our multiplication table. We're going to both display it a little bit different, but we're also going to iterate it just a little bit different. Once again, you can go ahead and comment out these examples here, these earlier examples. Ultimately, when you get done with this, I would encourage you to comment them or uncomment them again so that they all run. But just to keep the noise down, just to keep the clutter down when I'm printing this out, I'm going to go ahead and comment this. So what do we want to do differently? Well, the first thing is we're going to go ahead and build the for loop for the index outer. We're going to go ahead and start it at 0. Remember, we are back to integer indexes here. So we're going to start it at 0. And in this case, I'm going to go ahead and continue it just like the first example up to 12. But I want to make this less than 12. So we've got a couple of choices. We can either say less than or equal to 11, or simply say less than 12. And then the third part of this, of course, is going to be the index plus plus. Okay, I'm going to go ahead and switch over to the shorthand notation, index outer rather. And then for the inner one, we'll start off with for index inner equal to 0. Index inner less than, and like I said earlier, I want to keep this asymmetric. Instead of doing 12 times 12, I want us to actually recognize the orientation that we're printing out here. In this case, what I want to do is I want to specify index inner. We want it to stop at 9. We want to start at 0 and go to 9. So in this case, what we want to do is we want to specify value of 10, so less than 10, or as I said, we can say less than or equal to 9. And then our index inner plus plus. Now, in this case, what I want to do is I want to simply print the output or the result of the multiplication. So in this case, I'm not actually going to print out all the values. I'm going to simply print out %d, and I'm going to follow it by a comma. It'll seem a little strange here, but the idea is that we're going to have a nice then table-looking format or tabular-looking format for this output, a little closer to a multiplication table. You can also do it with a space. It doesn't really matter. And then here we simply want to multiply now the index outer times our index inner. Now, we're intentionally going to leave it like this. You're probably already noticing a problem. I'm going to go ahead and build this. I just want to see this in action here. And we're going to go ahead and clear our screen. And if we run this, you'll see that it prints out all of the values in one long line, all the way up to the 99 here, okay? And we'll come back to what's happened here in just a second. But in this case, let's go ahead and change this real quick now from a comma to a new line. Basically going to play around with this just a little bit so you can see the behavior. If we run this one more time, you'll see that it is stopping here at 99. And you'll notice here that what's happened, go ahead and bring this in here. So my index inner starts off at 0, continues up until 9. My index outer starts at 0, continues up until 12. But you'll notice here that I have values, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 0, 2, 4, 6. So what's going on here? Well, if you come down here, you'll see that I'm essentially row by row, I'm printing just simply the output values of the multiplication, but that's not what I want. Neither do we want this all printed horizontally, nor do we want it all printed vertically. So how can we accomplish this? Well, it turns out the simplest thing to do is to come here inside of our loop and simply stop this inner loop one column early. So in this case, what I'm going to do is I'm going to stop this index inner one column early. In other words, I'm going to stop it at 8. And then I'm going to add an additional printf statement with a %d followed by a new line. And I'm going to also repeat the calculation here, the index underscore outer times the index underscore inner. And let's go ahead and build this and see how this looks. So if you notice here, I'm going to rerun this. Tell you what, let's clear our screen. Run it one more time. The zeros aren't terribly interesting, and we'll come back to fix that in just a second. But notice what happens here. So I start off at 0, and up to and including 8 is followed by a comma. The 9th value, or rather the 10th value, but the index equal to 9, is followed by a new line. Now, how does that happen? Well, when we complete the inner for loop for the last time, the value of the current value of index inner is 8, and then when we loop back around, it increments to 9. That temporary variable is still valid. So in other words, we can still use it. And at this point, the value of index underscore inner is 9, because 9 is not less than 9, but that value of the index inner is 9. And so what we're going to do is we're going to leverage it one last time and for this final print statement. Now, normally we don't do multiplication tables based on 0 because it's kind of a useless calculation. Everything times 0 is 0. So there's one other little minor change we want to make. We could have started the index out at 1 and then let it continue until, while it was less than 13, 1, and then less than 10. But I did this intentionally because, as we've mentioned before, C is 0-based indexing, and we want to use this in the future to be able to build an array and actually store the values. And so what we want to do now is we want to leverage the relationship between the index and the value, in this case, that we wanted to print out in the multiplication table by simply adding 1 to each of the index values. So in this case, we're going to have index outer plus 1 and then index inner plus 1. Seems pretty straightforward. Let's go ahead and build it and let's see what the results are. So our table should look the same. It's being driven by the same indices. The only difference is that we're adding 1 to each one of the indices when we do the calculations. And now we see the multiplication table we were probably expecting to see. These values of 99, 90, and so on probably bothered you a little bit, especially when we expected to see something like 12 times 10 for the final value. So hopefully you found this video useful. As always, if you got any questions or comments, don't hesitate to email me, and thank you for watching.